Hi, Mr. Richards here, and today's lesson is on adding and subtracting polynomials. First, we have a little bit of vocab to get through. So, what is a polynomial? Well, a polynomial is a monomial or sum of monomials. And just to refresh, what is a monomial? Well, a monomial is a number, variable, or a product of a number and one or more variables. And an example of this could be something like 7x. That's a monomial. Then what's a binomial? Well, simply the sum of two monomials, such as 3x squared plus 8. What's a trinomial? Well, it could be the sum of three monomials, such as x cubed minus 8x plus 3. You're saying, wait a minute, minus, that's difference. Well, when you really truly think about it, adding a negative number is the same thing as subtracting a positive, so you can have subtraction here and still call it a sum. Now, what is the degree of a monomial? The degree of a monomial is the sum of the exponents of all its variables. And what is the degree of a polynomial? It is the greatest degree of any term in the polynomial. And it is worth noting that polynomials are named based on their degree. So if you have a 0 degree polynomial, that's called a constant. If you have a first degree polynomial, that's linear. If you have a second degree polynomial, that's called a quadratic. And if you have a third degree polynomial, that's called cubic. Now, our first example has us to determine whether each expression is a polynomial. If it is, find the degree and determine whether it is a monomial, binomial, or trinomial. Well, 6x minus 4. Well, this is, yes, a polynomial. And the reason? Well, it's the difference of two monomials. And is it a monomial, binomial, or trinomial? Well, there's two terms there, so we're going to call it a binomial. What about x squared plus 2xy minus 7? Well, this again is going to be yes. And our reason, it is the sum and difference of three monomials. And since there's three monomials there, we're going to call this a trinomial. What about 14d plus 19e cubed, all divided by 5d to the fourth? Well, these are not monomials, so this is just a no since we have the quotient there. And so really nothing else to write. And 26b squared, well, this is also then yes. There's just one term. And so this is a monomial. Now, what is the standard form of a polynomial, and what is the leading coefficient? Well, for the standard form of a polynomial, it is when it has terms in order from the greatest to least degree. In other words, x cubed, then x squared, then x, then your constant. And what is the leading coefficient? Well, once you're in standard form, it is the coefficient of the first term. So now we're asked, write each polynomial in standard form and identify the leading coefficient. Well, let's take a look at what degree each term is in. 9x squared, that's a second degree. 3x to the sixth is a sixth degree. And 4x is a first degree. And so we want to write that out, since these are the degrees, from greatest to least degree. So we'll start with our 3x to the sixth power plus 9x squared minus 4x. And that is the standard form of that polynomial. Now, the leading coefficient is not 9 here because it has to be in standard form. It is the 3. What about the next one? 12 plus 6y plus 6xy plus 8xy squared. Well, the 12 is a constant and it has a degree of 0. 6y has a degree of 1. Now, in 6xy, each of these x and y is to the first power, and so you have to add those up to get a second degree. And then again, this x here is to the first power, and 1 plus 2 is third degree. So right now these are from least to greatest, and for standard form we need to get it to greatest to least. And so this would be 8xy squared plus 6xy plus 6y plus 12. And that's the standard form of that polynomial. And the leading coefficient is the first one once it's in standard form, and that's an 8. There are two methods to find the sum of polynomials. The first is called the horizontal method, and the second will be called the vertical method, and we're going to practice both with this example. Now, if I rewrite our example with the horizontal method, 7y squared plus 2y minus 3, we're adding, so plus 2 minus 4y plus 5y squared. Our first step is to group the like terms. So my first term in this parenthesis is 7y squared. So let's put a box around all the y squareds. And that's it. So we're going to have 7y squared plus 5y squared. And now we're down to our just two y's, or our y that is. So this would be plus 2y minus 4y. And then lastly, our constants, a minus 3 and a 2. And now that the terms are grouped, we can add. 12y squared minus 2y minus 1. Now the second method, as already mentioned, is the vertical method. What you're going to do is write the first one out, 7y squared plus 2y minus 3, and we're adding. And now the key here is you need to line up the terms. So 7y squared will line up with 5y squared minus 4y plus 2. Notice how the terms are lined up by degree. And then we solve. Negative 3 plus 2 is negative 1. 2y plus a negative 4y is negative 2y. And 7y squared plus 5y squared is 12y squared. And so now we have 12y squared minus 2y minus 1. Both horizontal and vertical has its advantages. And as long as you can learn how to solve with both, you may have a favorite, but it's good to know both methods. What about 4x squared minus 2x plus 7 plus 3x minus 7x squared minus 9? Let's practice the horizontal method first again. So we'll rewrite this out, 4x squared minus 2x plus 7, then plus 3x minus 7x squared minus 9. Well, we'll start with our x squareds, our second degrees. Those are there. Missed it there. So we have 4x squared minus 7x squared. And now we're down to our first degree, our just x's. So plus a negative 2x plus 3x. And now we're down to our constants, our 7 and our negative 9. So plus 7 minus 9. And now as I put this back together, we would have negative 3x squared plus x minus 2. Now to practice this using the vertical method, make sure once again that your terms line up by degree. So that we have now 7 plus a negative 9, and that is negative 2. Then we have negative 2x plus 3x, which is just 1x. And then we have 4x squared plus a negative 7x squared, which is negative 3x squared. So again, the horizontal method and the vertical method. As we move on to subtracting polynomials, think about how we used to subtract integers. We would take the inverse, the additive inverse. We would keep change opposite. And we can do the same thing here. And if we're looking at, pretend you're subtracting 3x squared plus 4x minus 5, you can really add 3x, or negative 3x squared, add a negative 4x, and add a 5. And you can look at it that way. And so as we look to find the difference here, let's use the vertical method. Let's line up our 8y to the 4th plus 6y squared minus 5y. And we're subtracting 9y to the 4th plus 2y squared minus 7y. Now what we're going to do is change the subtraction into addition. So we'll have 8y to the 4th still plus 6y squared minus 5y. And now, as we change that subtraction into addition, we're going to take the inverse or the opposite of those three. So the 9y to the fourth becomes negative 9y to the fourth. The plus 2y squared becomes minus 2y squared, and the minus 7y becomes plus 7y. And now we add. Negative 5y plus 7y is 2y. And it's a positive 2y. 6y squared plus a negative 2y squared is a positive 4y squared. And lastly, 8y to the fourth plus a negative 9y to the fourth is a negative 1, or just negative y to the fourth. And that's the answer. Negative y to the fourth plus 4y squared plus 2y. Now you can also do this using the horizontal method, but we'll just stick to the vertical method for now. And as we solve this second example of subtracting polynomials, let's write this in standard form first. We'll have 11 n to the third power plus 6n squared plus 2n. And we're going to subtract, now make sure you line these up by degree, a positive 5n squared, a positive 4n for now, and then minus 3. And as we rewrite this into addition, we'll have the 11n to the third plus 6n squared plus 2n. And we're going to change this subtraction here into addition. We don't have any n to the thirds. This 5n squared is going to become a minus 5n squared. This plus 4n is going to become a minus 4n. And this minus 3 is going to become a plus 3. So now I can just simply add. I have plus 3, and then the positive 2n plus a negative 4n is a minus 2n. Then I have a 6n squared plus a negative 5n squared, and that is just 1n squared, or n squared. And then I have the 11n to the third. And that's the answer. So make sure we write it in standard form with our first number, or our first polynomial, and then line up your degrees, and sometimes you won't have any matching. Then we use the additive inverse, took the inverses, and then simply added. And now we come to our real-world adding or subtracting polynomial question. The total amount of toy sales T in billions of dollars consists of two groups, sales of video games V and sales of traditional toys R. In recent years, the sales of traditional toys and total sales could be represented by the following equations, where n is the number of years since 2000. R equals that polynomial and T equals that polynomial, except one little change that I do want to make here. As I type this question incorrectly, this addition sign needs to change. And it is going to change from an addition sign to a subtraction sign. My mistake, because I put this together. So write an equation that represents the sales of video games. Well, we know that video games V plus traditional toys R are going to equal the total toy sales. Well, if we're looking now to solve for V, we're going to subtract the R from both sides. And we're going to end up with video games is going to equal the total sales, T, minus R. So now we can take our T, subtract R, and that's going to be v. So we're going to take the t, which is 0.45 n to the third minus 1.85 n squared plus 4 4/10 n plus 22 6/10. And for now, we'll just write this as a subtraction of 0.46 or 46 hundredths n cubed. Again, make sure this is a minus 1.9, 1 9/10 n squared, plus 3n plus 19. Now, because of space here, when it comes to using the additive inverse, I'm just going to have to write this over in a different color. If you would like to rewrite this instead of writing over your signs, you could do that as well. So what we're going to do is to change this subtraction into addition. Then this positive 0.46 becomes a negative 0.46. This minus 1.9n becomes a plus 1.9n squared. The plus 3n becomes a minus 3n, and the plus 19 becomes a minus 19. Again, because of space, we just kind of wrote over these signs in a different color, and if you have room to rewrite this, go ahead. And now we get to add these together. So we have 22 6/10 plus a negative 19, and that turns out to be a positive 3 6/10. Then we have 4 4/10 n plus a negative 3n, which is a positive 1 4/10 n. And then we have a negative 1/85 hundredths n squared plus 1 9/10 n squared. And that turns out to be 5 hundredths n squared. And then lastly, we have 45 hundredths n cubed plus a negative 46 hundredths n cubed, which is just a negative 1/100th n to the third power. And that's the equation. Negative 1/100th n cubed plus 5 hundredths n squared plus 1 4/10 n plus 3 6/10 is equal to video games V. And so now as we have that, we can use the equation to predict the amount of video game sales in the year 2012. So we're going to rewrite our equation, negative 0 plus 5 hundredths n squared plus 1 4/10 n plus 3 6/10. And now n represents the number of years since 2000. And so 2012, n is going to equal 12. And so now we put in 12 for n. We're going to have negative 1/100th times 12 to the third power plus 5 hundredths times 12 squared plus 1 4/10 times 12 plus 3 6/10. Now, as you go through this, make sure you do the exponents first. So 12 to the third power is 1,728 times the negative 1/100th is going to be negative 17 28 hundredths. And 12 squared is 144 times 5 hundredths is a positive 7 2/10. 1 4/10 times 12 is 16 8/10, and then we have our 3 6/10. And as I add these numbers up, we have 10 32 hundredths, and this is billions dollars. And that is it for this first lesson in Chapter 8, Adding and Subtracting Polynomials. Good luck!